Graphs of trig functions.
Okay, guys, so it's 12 July, page 307. We're doing transformations and graphs of trigonometrical functions. If you didn't know what trig stands for, it's trigonometrical functions. So all the transformations that you guys are used to, like stretching and translations, will happen with trig graphs as well. Stretches, reflections, translations. And I think the best way to explain this is just to do an example. And that is on page also 307, example 8.15. They say, let's start with the basic graph y is equal to cos x and see what happens if we do the following transformations. There's 4 main things that you can do to transform this graph. Okay, so let's start. Y equals cos x. So if I can ask you guys, we're going to do 4 different Cartesian planes. And for all 4 Cartesian planes, I don't mind it if you draw like a small little Cartesian plane like that. And I want you to draw the original cos graph on each of them. I think for now, can we stick to degrees? Because Evan hasn't listened to the radian one yet. I don't know if you had some time to listen to the radian one.
Yeah, I did. Yeah.
It's quite easy. It's just a transfer of like going to degrees to radians. Okay, let me just quickly see. I want to make this one the biggest one. Cool. So cos graph, we have 4 critical values. Here we are, here we are. And then just the normal cos graph, courses op die tafel. Remember I said that, which means you'll start at the top and then every 90 degrees, something needs to happen. And what I mean with the top, it will be 1 and the lowest will be -1. And make sure that it's curvy. Make sure that you flatten out and you change concavity. That is my basic cos graph. Right. Now, if you want to, you can use different colors for our transformations. Maybe I should use a red. I'm going to draw cos 3x. Now, you remember maybe from transformations, if you mess with the x, it's like you are stretching or shrinking your x. So this 3 affects your x. So in this case, it will actually affect your period. The period at the moment is 360 degrees. If you now want to have a new period, you can say 360 divided by this value, which is 3. They call it the B value. Sometimes this is written as a B. And that will equal 120 then, which means if they do ask you what's your new period will be 120. Okay. Also, period is important if you want to know the step on your calculator. The step on your calculator, if we do table method, you take period over 4 to know what to step in. So we'll actually step in 30s. So I hope you left enough space to step in 30s, because that means we'll have small little things in between here, 30, 60, 90. I'm going to make 2 little steps in between. And then if you want a reminder of how to use your calculator, let me just remind you, you can type in mode, that one at the top, 7. And then you are in table method. For this one, I want you to check that you are in degrees. There must be a little d there. And then let's type in cos 3 alpha x. Just want to show you that it does work. You'll start at 0, end at 360, step in 30s. Because then you'll see, you'll start at the same point. I'm seeing from my calculator here, I'm starting 0, 0. 0 for x, 0 for y. 0 for x, 1 for y. Then I need to dip down already at 30. Do you see that? At 30, I'm going 0 and then dip down at 60. Then at 90, back up. Maybe it's easier to just make the dots and then we can draw them in the end. I think I'm just going to make my dots. Yeah, and then I'll draw it at the end. Try and still make it curvy. Mine's a little bit like a pyramid. You can make it more curvy if you can. Yeah. Oh, this is a different person joining us, Chelsea.
So,
He was never Chelsea before. Okay.
he was always Chelsea.
Okay.
That was always his name.
It's weird, I didn't realize that. Hi, Sahil.
Hello.
Welcome, welcome. Listen, you missed a little bit. I just recorded it. You can watch the video. Okay, we are on page 307. You just missed the first one. We were drawing cos 3x. Okay, so what you guys can notice here is that if you mess with the x, you basically shrinking this graph. It's not really a stretch, it's more shrinking. And your period will change. Can you see how many waves did I make in 360? I made 1, 2, ooh, I should be making 3. Let me just make sure. 1, that's 1, 2, 3 waves. Okay, that is where this 3 comes from. This 3 right there. Okay. When that one is done, I just want to quickly look at double I. Let's just see, did we answer the questions? Starting with that, show how the transformations can be used. I think I'm happy with that. Let's move on. I did ask you guys to draw 4 Cartesian planes for me. So the next Cartesian plane, make it a little bit higher if you can, because we're going to have to move this graph 3 units up. So even if you have just a small negative y-axis, I'm observing already what we're going to have to do, and it looks like we're going to have to move it 3 units up. We need to sketch the normal cos x, and then I'm happy we're using red again. We're going to use y equals, I prefer writing it like this if you don't mind, cos x plus 3. Just makes more sense to me, even in the exams. If they give it to you like they do at double I, you rewrite it like this. Okay. Which means if you remember transformations, it's just going to be up, an up movement. If you're moving left and right, it will be inside the x. If you're moving up and down, it will be after the x. Okay, so again, I would want to see just a normal cos graph. Counting in 90s is all fine. So you'll just remember in this question, we are in degrees. Okay, I just said to everyone we're in degrees, not in radians, just for the explanation part. So cos is op die tafel. So we start with normal cos on the table at 1, then dip down. You see, I'm doubting myself if I don't make my dots first. It's easier to draw the graph if you have dots. Now the easiest, I don't even know if you should type this into your calculator. It's just 3 units up. So if you count 2, 3, 4, literally each little dot that I was coloring in here needs to move 3 units up or translate through vector 0, 3. So 1, 2, 3. There we go. Just keep your concavity the same. Okay, so that's how you translate a trig graph up. What they love asking in questions like this would be, how did the range change? The original range was from -1 to 1, but now because of this +3, it's only from 2 to 4, if I asked you for range. They also say on the memo, they say the curve therefore oscillates between y equals 4 and y equals 2. That's like a sciencey thing. Hey, oscillates, I think it just repeats itself, right?
It's this thing.
Oh, is this okay? Completing.
I think so.
Okay. It doesn't. Doesn't change its pattern forever. I think that's what I understand for oscillate. But anyway, this will also never change. So I think this is also an oscillation process. Please don't quote me on this. This is being recorded. Okay. Let us quickly do triple I again with my sketchy. I'm not too worried about how high and how low you go. I think we can use 4 lines if you want. 1, 2, 3, 4. And then let's count in 90s. I do like counting in 90s. Makes me feel safe. Okay, so if I get, okay, I almost said a joke on this recording. If I get arrested, then I'll just count in 90s. Okay, I won't get arrested, guys. Then I want you to just sketch your original cos x. This should be a natural thing for you now. Even though I can't do it without my dots. Okay. Normal cos x, perfectly fine. And then just use a different color for this next movement. This is the worst one, I would say, out of all 3. If it moves left and right, because I've told you before, whatever you think is being done to x, it's the opposite. So if they say x minus 60, then it's actually plus 60. Okay. So if you want, you can type this into your calculator. Obviously, it makes it a little bit better. I'm going to put little in-betweenies here, which means I'm technically counting in 30s. Okay. That's also something I do want you to do on your calculator. As soon as there's a movement like 60, rather count in 30s, because 30s will also get up to 60. The reason why I want 30s is because some of these coordinates, if you move it from the negative side to the positive side, you'll actually get an answer of 30. So just trust me on this. Cos alpha x minus 60, in your table method, start 0, end 360, step 30. You don't have to use all of them. Use the nice ones. Like I'm have to start then with 0.5. Okay, so indicate that you're going to start at 0.5. I don't really like the 30, to be honest. I'm going to rather use, in this case, 60 and 1. Oh, okay, so be careful here. This is going to be 60 and 1. 30, 60 and 1. Then I like 120 again. This is a good one, 120. And then 150 is nice, 150. Oh, I should have been at a half. Ay, ay, ay. So this is very possible that you have incorrect dots. Don't let them lead you astray. 150, 0. Okay. 180, negative a half. 240, negative 1. 300. You see, I'm not using all of them. I'm just using the nice ones. 300, negative a half. 330 naught. And 360 a half again. Okay. Bit of a weird one, but now you know why you played connect the dots as a young child. There was a use. Okay, that doesn't look too bad. I thought it was going to be worse. So this is a graph that moved 60 degrees. It's actually obvious if you want to observe what was my movement. Here's a nice place to observe my movement. I moved 60 degrees to the right. Do you see? Because this was naught, normally the black one, and now the red one is at 60. So if you wanted to, I remember the way that I did it when I was in school, we didn't have these clever calculators. I would make the dots for my original black one, and then you just literally take all your dots and you move it 60 degrees on. As long as you know this is 60 degrees to the right. And it's a translation. You could have also said it's a translation 60 naught. Okay. They have all of this, by the way. They have very nice sketches in the textbook. This is just nice to see them happening live. Okay. One more to go, and then basically we covered all 4 of them. All 4 possible changes. There can't be more than these 4. Only problem is sometimes they combine them in one, which is a bit intimidating. Okay, last one. This one, maybe use 3 lines, just for space. But you can still go 90, 180, 270, 360. Now you know every 90 degrees, something major has to happen. You can draw your original. So that's my original y is equal to cos x. Now I'm going to show you how we're going to do a one-way stretch in the y direction. So it's going to look like this, 2 cos x. You can type it into the calculator if you're welcome, but I promise you this one is very easy. Just all that happens is you're stretching it. I'll show you. You're stretching it like this. Okay, so it can either be a shrink if it went to half, or it can be a stretch because it's 2, or if it was negative, you can even flip it. But let me just show you what I mean. All your critical values will actually stay the same if it's naught. So these 2 noughts, you can still aim for them, but just start at 2. That's going to be your highest, and your lowest is going to be negative 2. It's almost like your maximum and minimum are the only ones that will change. So obviously your range is changing as well. That's a very nice one, nice shape. So notice that your range is changing when you stretch it, when you do a one-way stretch y direction. That is it. That's the 4 changes. Obviously, Cambridge is going to take this to another level, but we're going to handle that as it comes. Everyone still okay? I didn't lose anyone?
No.
Okay. My 4 changes done. Now let's see how else they can ask you. Obviously, sketching could be a question, but finding a variable, that's also very possible. And your theory is important here, the theory that you just learned. One more example for this textbook. Guys, how does it feel?
Great.
Okay.
Okay, good. Obviously, 8F is also going to be the last exercise. And if you guys concentrate nicely for me, I won't give you homework. I will make you do this in your class period tomorrow, because I can sense that you guys are falling behind a little bit. Maybe the pace was a bit fast. Okay, so example 8.16, have a look at what they give you. They give you f of x, a plus b sine x. I would definitely rewrite this because my brain just works better if the plus a is at the end. Just a quick identification here. This was definitely a one-way stretch y direction, like a stretch like we just did. And this was an up-down movement. Well, I'm thinking it's going to be up if a is positive. Just before I do anything, I'm just identifying what type of transformations happened. Unfortunately, this is now in radians. So this might be a bit confusing for you, Evan, but it's not too bad. They're saying up until 2 pi, but you can just think of 2 pi as 360 degrees. Okay, we can even just do it in degrees and take the answer to radians. Okay, they give us some information. So they don't leave us without a paddle in the middle of the sea. They do tell you this, and they do tell you this. Just for Ivan, you can be in degrees. Okay, so this pi over 6, you can use 30 degrees. Okay, this is 30. So all I need you guys to do quickly is read this notation and know what's going on. So when x is 0, y is 4. I hope you know that. That means when x is 0, y is 4. Let's apply that to this equation, because you have a y, you have an x. So let's pop them in. Y is 4, x is 0, interesting. Ooh, 0. I know we're not going to necessarily be able to solve everything with this one equation, but there are 2 of them. Sine 0. For those of you in radians, you're going to use pi over 6 just now, but for the 0, it won't matter if you're in radians or degrees. Sine 0 is just 0. So 4 equals b times 0 plus a, and as easy as that, we know that a is 4 then, just by using this 1/2 of the information given. When you then look at the other half that was given, you can choose if you want to do this in degrees or in radians. Sub in for me. I'm going to do it like I'm doing degrees. So I'm going to sub this into y, and I'm going to sub 30 into x. And I have a. Remember, I just worked out a, and a is 4. If you want to use pi over 6, you put pi over 6 there, but then you must change your calculator mode into rad. All right, normal algebra, bring this over. This is 1. B sine 60 is a half, right? No, sine 30 is a half. Yeah, it's a half. So B is 2. And that's,
Yeah.
they asked that. What is A, what is B? Sub it in. So simultaneous equations algebra is now coming into trig. Not a problem, not a problem. And then they want you to find the range. You know what? I would first sketch it and then find the range, to be honest, because it's so much easier. If you look at C, they ask you to sketch it. I would first sketch it and then write the range. Your B is 2. And your A is 4. When we are sketching this, make it quite a large Cartesian plane, because we have to move this thing 4 up and stretch it by 2, which makes it quite hectic. So even if you have like, I think that should be enough. I'm going to do 90, 180, 270, 360. But you could have also done pi, half a pi, 3 over 2 pi, 2 pi, like they asked. Okay. And also it's in the textbook, if you look on page 311, they do it in pi form. So 2 things happening here at once. You're stretching sine and you're moving it 4 up. So 1, 2, 4. I need to go up to 6. What I would normally do if I didn't have a calculator, because obviously you guys can just type this into your calculator, your step 90. But I would have thought about the original sine. The original sine starts here. Because it's stretched 2, this is what will happen to, if I can just tell you that 2 sine x would look like this. Okay, that's 2 sine x. You're stretching it. But now you're also plussing 4. So I'm doing this the old school method. Move each dot up by 4. 1, 2, 3, 4.
Yeah, I think I got it.
Yeah, not bad, hey? Or the calculator can also, it could have helped you. It's nice to be self-sufficient as well, not growing dependencies here. You didn't have to do the other black dots, but that just guided me. And do you see what I mean with the question about range? It's so obvious now. I mean, range, yes, I can see y must be bigger than 2, including, or smaller than equal to 6. So it does help to sketch it, even if you sometimes just draw a rough sketch. Sometimes they don't ask you to sketch it for marks. If they do ask that, I just normally do like a quick stretch it, move it 4 up, move it 4 up, and then you can get your range, I mean, without actually sketching it. Yes. Sure, Sahil, if I didn't have elbows, you'd swallow me whole. Okay, listen, that actually went quite quickly. That was a hectic session. I'm going to stop the recording because it's